Hello class, welcome to SciChem. Here we are, another session for lecture 2 of chemical kinetics. Before watching the lecture 2, make sure that you have watched previous lecture on chemical kinetics. So let's start. So what are the factors affecting rate of reaction? In the previous class we have discussed about rate of reaction. What is rate of reaction? The change in concentration of any one of the reactant or product per unit time is called rate of a chemical reaction. So what are the factors affecting rate of reaction? There are various factors. So factor number 1 is nature of reactant and product. So first step, physical state. Physical state, we have three types of physical state. It is solid, liquid and gas. So generally, if we have to consider the reactivity of different types of substance, so I can write here rate of reaction is equal to gaseous reactant is more than liquid, and liquid reactant have a rate of reaction is more than solid reactant. In case of mixture, I can write here the rate of reaction of homogeneous mixture is more than heterogeneous mixture. Homo means same and hetero means different. So same type of substance will react faster as compared to different types of substance. So second case is surface area. Surface area. So what is surface area? It have been seen that rate of reaction directly proportional to surface area. With increase in surface area, the rate of reaction also increases. Simply considering dissolving of medicine in water. If we break the medicine, it will increase the surface area. So it will easily dissolve. In another, if I have to give another example, you can consider a log of wood burns lately as compared to when the wood is being cut. So next point, come to next part, chemical nature of reactant and product. So what are we have been seen that rate of reaction directly proportional to stability of reactant and rate of reaction directly proportional to stability of product. Sorry, rate of reaction here inversely proportional to stability of reactant and rate of reaction directly proportional to stability of product. If I have to give two example, consider dissociation of acid, that is CH3COOH gives rise to CH3CO minus plus H plus and HCOOH HCO minus plus H plus. In between two acid, which acid undergo dissociation easily? If I can say CH3CO minus is less stable and HCO minus is more stable. So as SCO minus is more stable, so this reaction favors. As I have already told, rate of reaction inversely proportional to stability of reactant. More is the stability of reactant, it will less react, and rate of reaction directly proportional to stability of product. As the HCOO minus ion is more stable, so it is so dissociation of formic acid is more favors. Then coming to next part, temperature. In most cases, the rate of reaction becomes double for 10 degree rise of temperature. It have been found that the rate of reaction becomes double or triples with each 10 degree Celsius rise of temperature, or in general I can write rate of reaction directly proportional to temperature. Then come to next part, catalyst. Rate of reaction directly proportional to catalyst. In order to increase the rate of reaction, we can use catalyst. For example, if we consider Haber's process, N2 plus 3H2 gives rise to 2NH3. Here you can use iron as catalyst, or in case of contact process, SO2 plus O2 gives rise to 2SO3. Here we can use platinum as a catalyst. So catalyst can increase the rate of reaction. The most important factor, that is concentration of a reactant. Before starting concentration of reactant, we need to understand what is concentration. Concentration is simply number of moles per liter. So concentration directly proportional to 1 by V, or concentration inversely proportional to volume. If I can say that if for a reaction concentration doubled, then rate of reaction 2 times increases. Consider, if for a reaction, if concentration doubles, then rate of reaction increases by 2 times. Then if volume is doubled, then rate of, here I have made a mistake. Volume is half. If concentration is double, then rate of reaction 2 times increases. If volume is half, then rate of reaction will be. What is the effect on rate of reaction? Simply, since we have seen that concentration inversely proportional to volume, if concentration becomes 2 times, then rate of reaction increases by 2 times, or concentration doubled, then rate of reaction increases by 2 times. If volume becomes half, then rate of reaction will be increased by 2 times. As much as simple that. Similarly, pressure of a gaseous reaction, if you have to consider pressure of a gaseous reaction, we have a formula, PV is equal to nRT. So P is equal to N by V into RT. So P is equal to CRT. Since all the chemical reactions are carried out at constant temperature, so T is constant and pressure directly proportional to C. Pressure. If concentration is doubled, then rate of reaction increases by 3 times. If pressure is doubled, then rate of reaction also increases by 3 times. Simply, again I am explaining, since concentration inversely proportional to volume, if concentration becomes double, then rate of reaction increases by 2 times. Consider for a reaction, if you want to double the concentration, and it have been found that rate of reaction increases by 2 times. For same reaction, if you change the volume, that becomes half, then what will be the effect of rate of reaction? Then the rate of reaction also increases by 2 times, because by having the volume, the concentration becomes doubles. Similarly, in case of pressure, we have PV is equal to nRT. If the reaction consists of gaseous reactant and product, then we have to consider PV is equal to nRT. So P is equal to N by V into RT and P is equal to CRT. Since all the chemical reactions are carried out at constant temperature, so T is constant and pressure directly proportional to concentration. As pressure directly proportional to concentration, if for a reaction, if we have to consider for a reaction concentration is doubled, then rate of reaction increases by 3 times. Then if pressure is doubled, then rate of reaction also increases by 3 times for any particular reaction. I am taking an example just. So P directly proportional to C. Then come to next part. And come to next part. What is the effect of concentration? What is the effect of concentration? The effect of concentration on the rate of reaction was studied by Goldberg and Wedge, and they consider a reaction that is A moles of A plus B moles of B gives rise to product. Then I can say that rate directly proportional to A to power A and B to power B. And this reaction, this equation is so called law of mass action. What is law of mass action? The rate of a chemical reaction directly proportional to molar concentration of the reactant, with each concentration term raised to the power equal to the stoichiometric coefficient. Here the stoichiometric coefficient is A for capital A and B for capital B. So by seeing simply theoretically, I can write the law of mass action. But however, experimentally it is observed that the rate of this reaction may not depend upon all the A concentration term. I can say that experimentally it was found that the rate of reaction may not depend upon all the A concentration term of A and all the B concentration term of capital B. Suppose experimentally the rate of reaction depends upon alpha concentration term of A and beta concentration term of B. Then law of mass action will be rate directly proportional to molar concentration of A raw power alpha into B molar concentration of B raw power beta, where alpha may be equal to A or alpha may be not equal to A. Similarly, beta may be equal to B or beta may not be equal to B. So what is the concept behind this? The effect of concentration on the rate of reaction was studied by Goldberg and Waj, and they found that for a reaction rate directly proportional to molar concentration of A raw power A and B raw power B, and that is law of mass action. But it have been experimentally found that the molar concentration of a reactant does not depend upon whole A concentration term of A and whole B concentration term of B. So they have experimentally found to what concentration term the power depends. So they come to conclusion, they modified the law of mass action into another equation, that is rate directly proportional to A raw power alpha and B raw power beta, and this equation is called rate law equation. This equation is called rate law equation. So simple law of mass action is theoretical concept, whereas rate law equation is experimental concept. So rate law is a experimental concept, whereas law of mass action is a theoretical concept. Then come to next part. Then come to next part. What is the effect of concentration on rate of So what is the actual effect of concentration on rate of reaction? So it has been found that the rate of reaction depends on concentration in a very complicated manner, which also changes with the progress of reaction. And effect of concentration will be known only when we know the order. Effect of concentration will be known only when we know the order, and here we have calculated the order. In the rate law equation, we have rate directly proportional to A raw power alpha and B raw power beta, where alpha is order with respect to A and beta is order with respect to B. So overall order n is equal to alpha plus beta. Alpha is order with respect to A, beta is order with respect to B. So alpha plus beta is the overall order of the reaction, and this effect of concentration on rate of reaction can only be known by knowing this order, alpha and beta. and this order we have to calculate experimentally. By seeing the reaction we could not predict or we could not say what is the order of the reaction. Order can be calculated only and only by experimentally. So effect of concentration will be known only when we know the order. So order means the rate of reaction depends upon which power of concentration. This is very important. Order means the rate of reaction depends upon which power of concentration. For example, here A power alpha, that means the rate of A depends upon alpha power of concentration. Similarly, the rate of B depends upon beta power of concentration. So simply order means the rate of reaction depends upon which power of concentration. Alpha is the order with respect to A, that means alpha is the order that depends upon alpha power of a concentration term A, and beta is the order that depends upon beta power of the concentration of B. So for an overall reaction or for a general reaction, I can write rate directly proportional to concentration or power order. By saying this reaction, I can say that rate directly proportional to concentration of power alpha, A power alpha, B power beta. In general, I can say that rate directly proportional to concentration power order. So rate directly proportional to concentration power order. By removing proportionality, I can put here rate is equal to K into concentration power order. This expression is called rate law expression. K is rate constant or velocity constant or a specific reaction rate, where K is the. So why this is called specific reaction rate? Why this is K is called specific reaction rate? Come to definition part of K. Why this is called specific reaction rate, I can explain. Rate constant may be defined as rate of reaction when concentration is unity. When the concentration, that is, if concentration is equal to 1 or unity, then R is equal to K. Here rate is equal to K into concentration of power 1 order. If concentration becomes 1, then rate is equal to K. So why this is called specific reaction rate? Rate constant may be defined as a rate of reaction when the concentration term is unity. So that's why K is called specific reaction rate. So again, the difference between law of mass action and rate law equation. By seeing an equation, we cannot predict the order of a reaction. Order can be calculated experimentally. Since the rate of reaction involves order, so order should be calculated experimentally. But by seeing a balanced chemical equation, we can easily write law of mass action. So law of mass action is a theoretical concept, and rate law equation is a experimental concept. So make some idea referring some book. So here next part is unit of rate constant. The unit of rate constant is K is equal to mole liter power 1 minus n time power minus 1. How it came, I can explain. So let us consider rate is equal to K into concentration power order. This is the important formula you have to remember. Rate is equal to K into concentration power order. So I have to calculate the unit of K. So I can rearrange this. K is equal to rate divided by concentration power order. Let us take order equal to n. It may be positive, negative, fraction or 0. Order may be positive, negative, fraction or 0. So K is equal to unit of rate divided by unit of concentration of power n. That will be equal to unit of rate will be mole per liter per time. Unit of rate, change in concentration per time. So which have change in concentration, that is mole per liter per time. So unit of concentration, that will be also mole per liter power n. Here mole per liter power 1, here mole per liter power n. Just take to above it. So I can write here mole per liter power 1 minus n time minus 1. So this is so called unit of rate constant. If n is equal to 0, that means 0 order reaction. So K have unit, K have unit, put here 1 minus n, 1 minus n, 1 minus 0. So that will be mole per liter time inverse. In the similar way, if n equal to 1, that is first order reaction, I can write here K have unit 1 minus n, 1 minus 1, 0 mole per liter power 0, that will be equal to time inverse. So by putting the value of n, I can calculate the unit of any order reaction. So this is about unit of rate constant. Remember this thing. Sorry. Then come to next part. What is the difference between rate and rate constant? So first come to definition part. What is definition of rate? The change in concentration of the any of the reactant or product per unit time is called rate of a reaction. And rate constant may be defined as the rate of reaction when the concentration is unity. So definition is I have already told you. Then come to next. For rate changes with time except zero order reaction. Except zero order reaction. Why except zero order reaction? Consider here rate directly proportional to concentration power order. If order equal to 0, then rate directly proportional to concentration of power 0, and that will be equal to rate is equal to K, and rate is constant. So except zero order reaction, rate changes with time. And here for positive order, rate decreases, and for negative order, rate increases. Rate depends on concentration. Similarly, rate directly proportional to concentration. If concentration will change, rate also change. except zero order reaction. Zero order reaction is only that reaction that does not depends upon time and concentration. Next, unit of rate, that is here mole liter inverse second inverse. It is the unit of rate. Then come to next part, rate constant. It is independent of time, does not depends upon time. Rate constant is independent of concentration, and it does depends upon temperature. Rate constant depends upon temperature, catalyst and activation energy. Next, unit of rate constant. Unit of rate constant is different for different order reaction. This is mole per liter power 1 minus n, that is time power minus 1. So these are the all basic concepts of chemical kinetics. So what are the factors? These are the factors affecting rate of reaction: nature of reactant, physical state, surface area, chemical nature of reactant and product. Simply remember, rate of reaction inversely proportional to stability of the reactant and directly proportional to stability of the product. More is the stability of the reactant, less will be its reactivity. Simply consider this reaction dissociation of acid. Temperature, rate of reaction directly proportional to temperature, and catalyst, rate of reaction directly proportional to catalyst. If you add catalyst, then it will increase the rate of reaction. Similarly, concentration of reactant, this is important. If concentration is equal to N by V, so concentration inversely proportional to volume. If for a reaction by increasing the concentration by 2 times, then rate increases by 2 times. For a reaction, consider, then if volume becomes half, then rate of reaction also be increases by 2 times. Similarly, for pressure, if the reactants are involving gaseous reactant and product reactions involving, so we can write here PV is equal to nRT and P is equal to N by V RT. So P is equal to CRT. C is the concentration. Since all the chemical reactions are carried out at constant temperature, so I can say that T is constant. So if T is constant, R is also constant, so pressure directly proportional to concentration. As pressure directly proportional to concentration, pressure and concentration have same effect on rate of reaction. By considering, if concentration of a particular reaction if doubled, then rate of reaction increases by 3 times. If pressure is doubled, then rate of reaction also increases by 2 times. Then what is the actual effect of concentration on rate of reaction? And rate of reaction depends on concentration in a very complicated manner, which is also changes with the progress of reaction. So the first effect of concentration on rate of reaction was studied by Goldberg and Watch. They are the French chemists, but they have proposed a law, that is law of mass action. But experimentally it have been found that the concentration but experimentally it is observed that the rate of reactions may not depend upon all the concentration terms involved in a stoichiometric coefficients. So they proposed another equation, that is rate law. So rate directly proportional to a power alpha and b power beta. So here effect of concentration will be only known if the order we know. So order means the rate of reaction depends upon which power of concentration. So rate directly proportional to concentration of power order. This is much more important. This is unit of rate constant, and this is the distinction between rate and rate constant. Thank you.